All right, now that we got that cohort out of the way. Morning, folks. It's always nice to see people continuing to come back like day after day once the cohort starts. So we're gonna dive in today, and we're gonna talk about objects. And this is normally the point in the first week where your brains start to bend a little bit, and start wrapping around some of the concepts. And so the trick here is keeping an open mind and recognizing that, especially with a lot of the stuff that's going to start today, the goal isn't for you to understand it 100%. The goal is for you to get a good sense of the fundamentals of each topic and then work on learning the rest of the finer points as we go through and start implementing certain things. Because if you are approaching this with a really traditional educational mindset, like if this was a university class or a secondary school course, then you're thinking, oh my gosh, I have to know this perfectly before I can move on to the next thing. And boot camp doesn't work that way. It will never work that way. So the goal here most definitely is work on understanding the fundamentals, and as those pieces start to fall into place, let the rest of the learning happen as you are putting hands on keys and doing things. Tony, when you go in, can you grab the door? Thanks. So that disclaimer being said, let's dive in. You might have read the little blurb on Compass this morning, and it talks about the fact that objects are just key value pairs. And key value pairs are something that we have all over our lives. We sprinkle them throughout everything that we do, and it's one of the main ways that our brain organizes information. And the term that gets used a lot is dictionary. If you think about a dictionary, it has two very distinct parts to it: the words and the definitions. And that is what we want to mimic. And so, like the blurb in Compass says, each language has their term for them because each language does them just a little bit differently, but it's all the same basic concept. And so this idea of a dictionary where words point to definitions, and what is the main thing, the main action that we take with a dictionary? We look up things. Yes. Extra points for Kira. Pretend I have a stack of virtual cookies on the corner of my podium, and I give them out as prizes. They're gluten-free, I promise. So yeah, we look up, like that is the actual action that we use when we are using a dictionary. The reason I want to start with that is because the whole point of an object is to allow us to organize information so that we can look it up later. So let's start off with a really basic example. So I'm going to say I hope I never have a student named Bob. I've gone 5 years and I've never had a student named Bob because it's my generic name to use. If I ever have a student named Bob, I'm done. But this is our syntax for an object, basic syntax for an object. So there's a couple things going on here syntax-wise that I want to go ahead and talk about. We are taking, like this part here is the object, and we are taking that and storing it in a variable called obj. And so that means the object is a thing. It is its own entity. And when I like to talk about objects, it's data and the methods to act on the data, which is helpful for us to think about. And it's times like this I don't like Sublime that much, but all we've done is we've given it data. we've defined a color, a size, and a name. Those are our keys, and blue, 12, and Bob are our values. So that's the data, but there are a lot of built-in methods that we get because objects are native to JavaScript that allow us to work with this data. And that gives us all of it combined into a single thing, which is kind of neat. And if I want to look up anything from this object, I'm going to use dot syntax. So first I'm going to borrow our good friend console.log, and I'm going to say object.color. Anyone want to take a wild guess at what this is going to return? Blue. Banner gets an extra point. Cookie. So yes, blue. And in order for us to understand what happened there, we have to get really, really pedantic for just a moment. I'll try and make this as painless as possible. But we had three things happen. The first thing that we did was we gave it obj. Obj is just a variable name. So JavaScript had to go to memory and figure out what was stored in that variable name. That happened first. It returned this object back to the code. That's the data that's stored in that particular variable name. Then we used the dot. The dot in JavaScript is the property lookup operator. That dot actually has a name and it has a job. Its job is to look up a property on an object. And so we told JavaScript, hey, cool, you gave us this object back. We now want to look up a property on that. We want to look up the property called color. So JavaScript went into the object, found the key named color, and returned to us the value of what was stored there. So we literally looked up that key in the object. And that's what happens every time we access an object, no matter what's stored in there. So if I wanted to say console.log object.size times 2, that would be 24. I'm looking up what's in obj, returns an object, property look up the one called size, that returns the integer 12, I multiply it times 2, I get 24. I promise that's the most math I will make you do all day. And the same thing would happen if I access name. I'm looking up in the object based on the key name, and it returns the value to me. Nice and straightforward. Doesn't matter how many keys I have in the object, doesn't matter what they store. That's the basic mechanic that we have with objects. And the cool thing is, even just writing this pretend code, we already did that in a different way. Console.log. It's an object. Console is an object that has a whole bunch of keys stored on it for different things that we can do on the console. Property lookup operator. I want to look up something on the console object. I want to look up log. But there's something special about log because we stuck parentheses on the end of it. What is log? It's a function. And so that tells us something new about JavaScript syntax. As soon as we stick parentheses on the end of a word, we're invoking a function. So if I come up here and I add a function, like I add another key, and that key is a function, stores a function, then I have two different things now that I can do. I can do that, or I can do that. Now I'm going to tell you right away that both of these are trick questions. What does line 16 log out? Hmm? It doesn't, you mean like it's going to log out this here? Vanna. No. Nick? Okay. So what we're going to do is we're actually going to take this and we're going to go into the REPL. So I've got my function defined. And if I retrieve my function, that's what I get. And so anyone else want to put a guess in before I hit enter of what it's going to log out? I'll give you a hint. The answer's on the screen.
Is it what's between the square brackets, that function, left?
Yes. I don't know your name yet. Rohan, you get a cookie. Yeah. So this is a reference to the function. This is the definition, basically, of that function. JavaScript isn't going to show us all of the code in that function because it has now taken that function and compiled it to run as a function. But it's telling us that what is stored in object.laugh is a function. Now, if we run the function, so we do the lookup of what's in OBJ, we do the lookup on the object to find out the laugh property, and then we stick parentheses on the end of it, that's a separate piece of syntax, we get ha 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 ha. And then we get the return value for the function. So, what is this going to output? Like I said, trick question. But I'll tell you, the answer's on the screen. Close. So, the first one, the ha 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 ha, is what happens when we looked up the function and then ran it. This undefined is what was returned from that function. So we console.logged whatever was returned from that function. So we technically logged out ha 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 and undefined, and then this undefined is the return from console.log. So two of those are output, one of them is a return value. And this brings us to an interesting world within JavaScript, which is every single action you take, every single operation you do in JavaScript has a return value. You ever gotten the spinning beach ball or the hourglass on Windows? Blue screen of death, any of those things? That's a function that did not return or is waiting for a return. The return value from each operation is actually what causes your CPU to do the next operation. Without a return value, we don't keep processing our code. Code moves line by line by line by line because each operation returns something which pushes it forward, tells it to do the next thing. So console.log, by default, returns undefined. Our object.laugh method did not have a return in it. So by default, it returns undefined. All functions in JavaScript, by default, return undefined. So that's why we got these two as output, and then this one as a return. Okay, so let's go a little bit further with objects. So with objects, again, we have the ability to store whatever type of data we want. So I could say have a games object, and let's say that I am playing Yahtzee. What do I play Yahtzee with? Dice. So I might just say, 5 dice. If I am playing bocce, can you play bocce? Yeah, okay, thank you. This is the interactive portion of the day, by the way. I know it's early. Now let's say that I'm playing blackjack. Cards. So I might go so far as to do this. Etc., etc., etc. Pretend I typed all that out. Watching me type is not the fun part of your day. So now I have something a little bit more interesting going on. Now I have an object where one of the keys is an array. And this starts to get into what we would call a complex data object, meaning it has mixed data types in it. And so if I'm looking at this and I now want to fetch from my games library what I'm going to play blackjack with, I could say this. And what is stored in deck at that point? That array. Bingo. So then if I wanted, let's say, the third card from the array, you're right on the index, but I don't have to go all the way back into games.blackjack now. Yes. So now I can do that. But I like where you went with that because this is also the same as that. And now we're starting to really dive into that lookup mentality of how this data is stored. So we start off, we tell JavaScript, hey, look at what is stored in the games variable. Then we want to do a property lookup on that because it returned an object to us. And so then we want to find the key that is blackjack. And then that's going to return an array to us. So anytime we have a word, square bracket stuck to the end of that word, we know we are dealing with an array. We're dealing with, a set of data at least. And so then I look up index 2, and that will, of course, return this to me, which is what I want. So now complex data objects don't scare me because I understand that I'm looking up in a chain, and at any given point, I can literally take my hand and put it over the code and go incrementally and know what's coming back at each step. Like, no lie, I've actually taken like Post-it notes and put them on my screen until I could figure out what was coming back at each stage of that lookup. Because I, as a human being, don't have to hold all that in my head at once. If I can, great, thumbs up. If I can't, I only need to know what's coming back at each stage of that. So then I only have to remember one thing at a time. Einstein has a great quote, anything that can be looked up doesn't need to be remembered. So I don't have to remember everything that's stored in this games object. I can just go through it incrementally, and even if I have to like scroll up and down to figure out what's going on, I can figure out what I'm working with at each step of that lookup. So pretty useful. So now let's go one step further. Let's say that we were playing something a little bit more complex like, chess, okay. Sure, we'll go with chess. And so now what we're going to have is an array of pieces, but each piece is going to be an object. So she can move in 8 different directions. And let's add pawn. And the pawn can move in 2 directions. Well, 3 technically. Word wrap. There we go. So now we have something a little bit more complex. And I will format it a bit more nicely so that it's easier to see. There we go. So now it starts to get a little crazier, but we're okay with that because I can do games. I know what I'm getting back there. I'm getting back an object. And I want the chess key. Cool. That's going to give me back an array. And I want to know how many moves, how many directions the queen can move in. Well, in order to get the queen, I have to get the first index. And then when I get the first index out of that array, that's returning an object to me. Oops, I can type, I promise. So it starts to look more complex, but when you just break down from left to right what's coming back at each step, it gets a lot easier to work with more complex data. Have I lost anybody yet? Now's the time to be honest. Cool, no brain melting, good. So it is also equally valid for me to say that, and then totally valid, 100%. The question becomes, which one is better? As I always get asked that question at this point, so I head it off. There are pros and cons. We'll call this method approach number 1. We'll call that method approach number 2. There are pros and cons to both of them. What are some things you like about one or the other? Be opinionated. Yeah.
About the first one, it's just in one line.
Mm-hmm.
So the code isn't too long.
Right.
The second one is more easy to read.
Mm-hmm. Anybody else want to add anything to that?
I would say if you're going to reuse, sorry, did I interrupt?
Oh, no, go for it. I'll get to Nick.
I said if you're going to reuse the queen a bunch, it's probably better to use approach number 2.
Excellent. Nick?
Yeah, if you have a really, really long, nested series of objects, then approach 2 is much easier to read.
Right. And you're all correct. The truth is here, this follows that idea that software development is opinionated. You will have people that will argue until they are red in the face that one or the other version is the right way to do it. And I'm here to tell you, without exception, working code is worth more than pretty code any day. It needs to work. That's point number 1. Doesn't matter how pretty it is if it doesn't work. Both of these work. So if both of these approaches work, then you're going to pick the one that suits your use case at that moment. Great point. If we need to access the queen again later on in this function, later on in our code somewhere, then approach number 2 makes a lot more sense than having to continually go and do games.chess index 0. Whereas, to Banna's point, if we, just one line, boom, we're done, we got the data we need, it's out of the way, we're done with it. Approach number 1 is great at that point. You're always going to be chasing readability, and you're always going to be chasing maintainability. It's got to be readable, it's got to be maintainable. Because if I start with this code and let's say I do approach number 1 here, and I build the app and all of my access is this version, and then I'm done with the app and I hand it off and Kira now has to support this app. If she doesn't like this approach, she's going to curse my name. Doesn't matter if the code works or not, it's not readable and maintainable by her. If she likes this approach, awesome, she's going to be like, good, he did it the way I like it. Some people will get approach number 2 and hate it because it's technically an unnecessary variable unless you're reusing queen later on. Why should I have to why should I have to store it in queen if I can just get to what I need to with games.chess0? So it is entirely a style issue. And I'm trying to burst the balloon of there is one right way to write your code. There isn't. The right way to write your code is make it work. Solve the logic problems first. Once you solve the logic problems, the rest of it gets easier, like far easier at that point. Okay. So, two different approaches here for pulling this data out of a complex data object. But now, just because I like doing it, I'm going to complicate things just a bit. So what I'm going to do, that was not what I wanted to do. What I'm going to do is I'm going to grab this games object again. And I'm going to say that the game we want to play is chess. So now I've got my games object, like my games library, all my data is stored in that object. And I have another variable called game, singular, and that's the game that we want to play. The question becomes, how do I take the data that is in line 11 and use it to get the data out of games on line 1 that I want? Does that work? No. Why not? There's that, but there's one more reason down the ladder, more fundamental why that doesn't work. You get 2 cookies. See ya, right? Benita. Okay. Sorry. I'm learning. Cool. Yes, there is no game key on this. At this point, this is not interpolated or not interpreted as a variable. That is all. Whenever we do the property lookup, whatever follows the property lookup operator is never treated as a variable. Will never happen. It's taken as literal text. So that is, if I do object.anything, that anything is going to be treated as the literal property name that we're looking for. So I need to have now a different syntax that allows me to evaluate game as a variable and fetch the data from it and use that to get the data I want out of the object. And that's where we get this syntax. So this is our array syntax that we would normally use. But if you remember, I said earlier, anytime we see a word immediately followed by square brackets, we know we're dealing with a set of data. It's not always just an array. Those square brackets are a different kind of lookup. If it's an array, then what's inside the square brackets is going to be a number that represents the index we want to look up. But if what's on the outside, in this case games, is an object, then what is inside the brackets is going to be treated as code to find the right key. So this allows us to, have a games app that we've built and start off by asking the player, what game do you want to play? And they can either choose from a drop-down or type in a game name if they want. We can build a cool autocomplete for it. But they're going to give us data, for example, for what game they want to play, and we're going to take that back to our library and see if we have that game to play. This now allows us to dynamically look up something from an object. But in this case, that's going to return my chess array. And more word wrap. There we go. So that's what's going to get returned there. So now I have 2 different syntaxes. I have 2 different ways to look up a key on an object. but I'm still using that basic idea of a dictionary, where in the dictionary I look up the definition based on the word. In this case, I look up the value based on the key. If I know the name of the property ahead of time, I can use dot notation. If it is going to be dynamically generated in any way, if it's going to be variable, it's a good name for a thing that holds data. Sorry, that was terrible. I'm famous for dad jokes, I'll just warn you now. Yeah, if that data is going to vary, then I'm probably going to want to use square bracket syntax. Both are 100% valid. For the rest of your days as a JavaScript dev, you could use square bracket syntax, and I could just say like games blackjack. Just put a string in there, and that's going to look up that property name on my games object. And in this case, it's going to return that. So for the rest of your days, you can write it that way. But it's not as clean as that. Both work. Readable, maintainable. One's a little bit cleaner than the other. If you know the property name ahead of time, always use the dot notation. If you don't know the property name ahead of time, plan on using square brackets. And in either case, those square brackets give you the lookup ability for your object. Questions? Yeah. Is one more efficient than the other? Okay. I'm going to give you an answer that's going to sound snarky, but it's really going to illustrate the right answer to your question. If your app ever gets to the point that the difference between dot syntax and square bracket syntax on an object property lookup is what is slowing it down, you have way bigger problems than your object syntax. Does that answer your question? Okay. Yes, one of them is technically more efficient than the other, but we are talking shavings off of nanoseconds. Yeah. At the end of the day, they're treated pretty much equidistant. There's no human way to detect the difference between the two of them. Yeah. Yes. Mm. Let's find out. So we have our OBJ defined here that we started off with. So what happens if I do this? I get back nothing, unfortunately. And so the reason for that is because while the set of keys can be accessed kind of like an array, they don't get a corresponding number with them. But there is something cool that we can do. So the object in JavaScript gives us a method called .keys, and then if I give it my object, I get back an array of the keys, which means if I say this, if I save those in a list, then I can say for var I equals 0, I is less than list.length, I plus plus, and I can console.log obj square bracket list square bracket I, which looks ugly, but if we look at what's going on here, it will make perfect sense, because now we know how JavaScript is looking things up. JavaScript is going to work from the inside out. So I is going to get replaced with whatever the current index is in the list, like the loop incrementer. List is my list of keys, this array. So it's going to look up based on the index. It'll start off with color, then size, then et cetera, et cetera. And that word is then going to get put inside the square brackets to look up that key from the object. And we get that. Similarly, we also have object.values, which gives us an array of the values. So the long answer to your question is yes, there's a really good way to do what you want to do. It's just unfortunately not as easy as just doing a loop over numeric indices. You have to do one more step to get there. But this also goes with what I said about objects are data and the methods to act on that data. So there are methods that JavaScript gives us to be able to work with the data we have in an object. Oh, yes. Mm-hmm.
Object and just return like 0, 1, 2 instead of the actual property.
Okay, so you had an object that had nested objects inside of it. Okay, so let's something like that. And then you did a for in loop on the outer object. Okay. And then what were you trying to access inside the loop? Okay. We'll just log out whatever that thing is to start with. So I get back A, B, and C. If I change that around, to a different loop, I get this. So here's the fun part about that. If you want to get the properties in there, then what you're going to do is that. Because the for in is returning the keys themselves to you, which is a cleaner answer to what you were asking before, but I wanted to answer your question with a for loop, like a regular for loop. So yeah, the for in is going to return the keys to you, so you actually have to use the square bracket notation to look up the values, and then you get what you were looking for. Make sense? Okay. Cool. Which kind of inadvertently but cleanly is the next thing, which is you can have objects inside of objects. Like we just put an array inside of objects. That always freaks me out when they do that. But you can have objects inside of objects. And the lookup doesn't change at all. In fact, given this particular object right here, the nested one, if I wanted to look up the property of E, then I would do nested.c.e, and I get back what I expect. And the same thing is happening. Nested goes to memory, looks up what's stored there, returns the whole object back. I do the property lookup. It looks for the property called C. That returns an object. Cool. I do a property lookup, and then I look for the property called E, which returns its value to me. Doesn't matter how deeply nested this object gets, and trust me, if you ever work with the Instagram API, oh my God. Like, there's a whole chain of nesting that goes on there. It's ridiculous. Because you'll search for a keyword, so it will return an array of objects, and each object then has an images property. That images property is an array of objects, and each one of those objects then has like a name and a URL, and there's the short URL and there's the long URL, and each one of those objects is like full size, reduced size, like you'll get 10 or 15 different versions of the same image for everything that you look up, and it's just ridiculous how deep you end up going. But I can get whatever I want out of this object just by understanding what the chain of that lookup is going to be. And then if there was an array, like let's say I do something crazy, and I add a key, which is an array of fluffy, bunny, asparagus, random words. So now when I look up nested, that's what I have. So now I can go nested.c.f1 and get back bunny. So I'm able to delve as deep as I want as long as I understand what's happening from left to right with each lookup. Cool beans? Take a break. Okay. So, much simpler example than we had before we took a break. But now I'm in the position where I really want to take advantage of the data of my object. And so I want to be able to create the full name based on the data stored in the object. So I could, of course, I can do that and it will work, but it's kind of a pain to have to redo that every single time that I want to output the full name. So the challenge then becomes, can I give a method here that will allow me to generate the full name? And that would make sense if, if an object is data and the methods to act on that data, then I should be able to have a method here that can act on the data inside the object. The question becomes, how do I get to first name and last name from inside the object? Well, JavaScript gives us a really handy keyword for doing that. And that keyword is this. And just because of the way the English language works, I officially apologize going forward for every time that I have to say this in this lecture. So, within the function, within any JavaScript function, the keyword this always refers to the object that invoked the function. So let me show you how that works. We'll start off with just first name. If I do this, it will output my first name as we want. And the reason is we can figure, well, the way we can figure out what this is a rule called left of the dot. So that's another reason why I was picky about calling the dot out as its own separate thing. So the dot is the property lookup operator, which means it's technically kind of separate from the object to the left of it. So in this case, actually, my fault. This is going to do what we want it to do. When we get the teacher object back and we look up the full name property on it, if I then run that as a function, because I'm running that as a function, what is left of the dot is the teacher. The teacher is the one that ran the function. The teacher object is what had that property looked up on it, returned a function, and then we ran the function. So therefore, teacher is this. That's what this gets set to. JavaScript does that for us automatically. And let's actually put this into the REPL so that we can see it. If I do teacher.fullname, I get back Don. And if I take teacher and .fullname and I redefine it, then we get back what we would expect. So this is what we call a reflective property. It's a keyword that's automatically created for us by JavaScript. It is honestly created every single time you run a function, no matter what. JavaScript automatically creates this for you, and it will automatically store a value in this that is going to reflect the object that ran the function. because it changes every single time we run a function, it can sometimes produce some interesting behaviors. For example, let's say that we have, let's say we add another property to our teacher called suspense, and it's going to be a function. And then I'm going to do a set timeout. There we go. So what looks like it should happen is that if I run teacher.suspense, teacher's left of the dot. And therefore, the first console log should say Don waits, ... And then set timeout's going to wait for a second. And then theoretically, it's going to say Don yells boo. Unfortunately, that's not what happens. The reason is there's a new function inside set timeout. And therefore, new function means something different ran set timeout than teacher. What runs set timeout? Kind of a trick question, kind of not. I'll give you a hint. It starts with N and rhymes with bode. Node. By the way, Node is the environment that we run JavaScript in on the command line. Welcome to boot camp. No, set timeout is a built-in JavaScript method. So that's being run by Node itself. So it's actually the same as if I do global.setTimeout, because it's a global method. Well, like I get a reference to the timeout when I do that. Like it's built into JavaScript. So that means something new ran set timeout, which means something new was running that function that ran after a second. Whatever that thing was, it didn't have a first name property, so we got back undefined. Every time we run a function, then the context of this changes. It has a different scope. But inside of my function, it does exactly what I want it to do. So I now have a way to build a function and have that function refer to data stored inside the same object, which is kind of cool. And if I were to, let's do something crazy. I'm going to make an object for KV here, and we're going to give it the same properties. Just going to give it those two. And I'm going to say kv.fullname equals teacher.fullname. No parentheses here. I'm not running the function. I'm taking the definition of the function and moving it over to kv. And now, if I do kv.fullname, all votes for Crum Verani. All votes for Don Burks. All votes for I don't know if I should put my hand up or not. Cool. I like honesty. It's being run on the KV object. Therefore, left of the dot tells us that this will be defined as KV. And KV has his own first name and last name properties. And if I run this one, so exact same code in both places. This dot first name plus space plus this dot last name. Exact same codes in both places. But because this refers to different objects in those two cases, we're able to get different data. Kind of a cool feature. That means I now have behaviors that I can reuse in my code. I can figure out what properties on an object I need, and if I have 100 objects that all have the same properties on them, then theoretically, I can have that same method do the same thing on all that different data. That gives me flexibility. That keeps me from having to rewrite stuff manually over and over and over and over. So that becomes kind of cool. So let's actually do an interesting little example here. So I know I said I wasn't going to make you watch me type, but we're going to watch me type for just a second. And what we're going to do here is we're going to start off and we're going to make a list of objects. And we're just going to do one suit, don't worry. By the way, I always actually, when I'm writing real code, I code in Vim. It's not just because I'm old. It's because I've been using Vim for like 20 years. So the idea of having to use another editor to write real code makes me feel uncomfortable. So yeah, you'll see me code in Vim. That does not mean that you have to code in Vim. In fact, I do not advocate juniors coding in Vim. It's its own special editor. But yeah, if that ever bothers you, sorry. Yeah. And I need one more. A little bit more typing, sorry. Okay, so here we have a deck of cards. And an array of objects. And I'm going to make a function called printName, which is going to return, well actually, yeah, we'll have it return so I've defined this function here outside of an object by itself. Doesn't matter because what this is defined at this point doesn't exist. I'm not running this function right now, I'm just defining this function. So I'm not hard coding any value for this. If anything, what I'm now doing is making this function something that I can add to every one of my cards and then be able to run that function on that card. So I'm going to take the element out of the deck, and I'm going to add that function to it. So this way I can just loop through my entire deck and add this function to every card. And then I'm going to run that function. And then it's going to run on each card in that deck of cards. Which means what's left of the dot, in that case, at the point where I'm running the function, is this. So that's the individual card. And it does absolutely nothing because I forgot to do console.log. That was an opportunity to have you debug, but then you'd just be like, oh my god, he does not know how to code. So, and there we go. So I can now define a behavior. I can apply that behavior to an entire set of objects and get different output each time, because the keyword this allows me to refer to each object as I'm running that function. Cool? Make sense? Awesome. So, with that in mind, we're going to now do something interesting. So, I'm going to make a function replace where I'm going to reset the parameter that gets passed in with an empty object. And I'm going to make a function update which is going to add a new key to that object. In neither case am I returning. Okay? So now nice, simple object. And I'm going to run replace on it. Then I'm going to run update on it. And before we actually run this code, we're going to guess what it does. So, line 15, I'm running the replace function, and I am passing an argument that is the myObject variable. So that has an object stored in it. MyObject goes up and becomes obj on line 1. Line 2, I take obj and I completely reassign it to be an empty object. What am I going to get on line 16? All those who vote for empty object. Okay? All those who vote for the original object. All those who have no clue. Cool. Original object. So let's figure out why. So we pass my object in, it becomes obj, and we reassign it. So that is reassigning what is stored in the local object, the local variable in that function. But because we don't return it and reassign it to my object, it never gets reset. Yeah.
So I thought that whatever you assign in JavaScript in a certain function, it affects the global.
You're close. So in this case, obj is only a local variable, so the scope of that is just within that function. So my assigning it there only affects the local variable. But what you're talking about is where we're about to go. So, as you've probably guessed, we might be experiencing slightly different behavior here than what we saw before. So I'm going to take my object again, and I'm going to pass it to update. So my object is going to become the locally scoped variable on line 5 called obj. I'm now going to add a new key to that object called new key and set its value to be the string wee. But I'm not going to return anything. All those who suspect that my object is going to have a new key on it? All those who think it's not? All those who lost me back on replace and haven't caught up yet? Cool. I love the looks on people's faces when I do that. It's fun. It's one of the best parts of my job. So here, the reason I called this file reference.js is because we're dealing with something called pass by value versus pass by reference. JavaScript, when we pass an object into a function, we are passing by what's called reference. So you remember where I pulled the function and I just got back square bracket function? Because that was a reference to that function. The same thing happens with objects. When I pass my object in, it's a reference to that object. Now, with it being a reference to that object, if I update it, then every instance of that object updates, which I think is close to what you were talking about. Whereas my reassigning that local variable didn't alter this object. In fact, there's a really cool thing that happened up here, which is this created a brand new object and replaced what was in memory here. So we just ignored basically the original object that was passed in. Whereas here, we're actually directly accessing that object and adding to it. So it's in both cases, when I pass this as an argument here, it's a reference to that object. And when I update it, I get new keys. So any changes that I were to make to that object, if I removed keys, if I added keys, if I now made an object of objects of objects of objects, I would be updating the same object. There's basically just one object being used here in all of those places. But what I did on line 2, that's actually syntax that tells JavaScript, hey, create a brand new object and put it in memory where this variable points to. Basically, I have a box labeled obj, and whatever was in there before, forget that, create a new object, put it in the box.
But would it be called OBJ or my object?
It would be called obj. Yeah, because it's locally scoped inside that function. Anytime, so terminology, on line 1, where obj is in the parentheses, that's called a parameter, and that's where we define a local variable for our function that is going to accept data passed in.
Yeah, but I thought I meant like you called it, you replaced my object.
Well, I did, but all I did was here, the reason I said terminology is now at this point, this is an argument. This is the data I'm passing to that function. So what obj originally got, what obj originally got was a reference to my object. But then we literally replaced it with a brand new object. Make sense? Kira. Uh-huh.
So if we were going to do this with cards, say function replace, we would have, instead of object, we would have something like,
Card.
or hearts, like for different games. So the object that we're replacing.
Sure.
And then the variable of my object could be something like, I don't know, go fish. So we would still have all the cards in go fish, and then we would be basically taking all the cards from go fish and putting it into the new object, which would be cards. Does that make sense?
Not even close.
That's good. I'm glad that my confusion is over.
Yes. We have to separate what we call the variable from what's stored inside of it. I can call this variable on line 2, or on line 1. I can call that variable Otis, for example. And that doesn't mean that what's stored inside of it is a dog. It's a convenience term. So I could call it array and put an object inside of it. So yeah, when we're talking about replacing, literally what I'm doing is taking the object that was stored inside of that variable, throwing it away, and replacing it with a brand new object. Yeah, no problem. Does that clear that up? Good. Cool. Anybody still lost on what this does? Cool. Where did I lose you?
It's just, I don't know why, okay, like, it doesn't matter what you call it inside the function thing, like, you'll leave it as, like, in the brackets in the place.
Yep.
So why does it matter for, like, the second function?
What matters isn't what I'm calling it. What matters is how I'm manipulating it. So in line 2, I'm reassigning that variable. Like I'm just giving it a brand new value. And I'll give you a little bit easier example. Let's say I made a function add, and I gave it x and y. And its job was to normally return x plus y, right? And so if I do this, we would expect to get 4. What if I do this? I'm going to get back 7 instead, right? Because I'm just replacing the value that's in x. Same thing's happening on line 2 on the right-hand side. What I've called it, irrelevant. It's how I'm manipulating it. So then, on the update function, sure, I've given it the same name, but what's happening here is I'm taking that object that I passed in, and I'm now adding a new key to it. And so what's ultimately happening is I am updating the my object that I'm passing in, because it's what I passed in is a reference to that object. Pass by value would mean that I copied that object into the new variable. And that's a mistake that a lot of people make when they first start working with JavaScript. They pass an object in and they think it's being copied into that new variable. It's not. It's just, I've basically just said, here's where my object is in memory, please use this. And then whatever I do inside the update function affects that same spot in memory. Does that help a little bit? Are you being honest? Okay, cool. A little bit. It's like, yeah, Don, it helps, but please stop talking. It hurts right here. Yeah. Mm-hmm. Yes. So you're saying if I did this. Okay. Well, when in doubt, well, actually, let's leave that. Yes. So without rescoping that variable and giving it, var, so that it is scoped just inside that function, my object at that point is going to refer to the one in the global space, and it is going to reset it. And that's just variable assignment. That's not anything funky with objects. The same thing would happen if I had the string Beelzebub in there. But then, because that object has now been reassigned, when I pass it to update, it's going to update that object, and we get back something that is new key, we. Make sense? Cool. Yes. Okay, so if I put, well, for starters, this doesn't, let me change this. You're basically asking, what if I do that? I mean, the thing is, returning a variable assignment doesn't really do what you think it's going to do, because if I say var x equals 5, I get back undefined. If I then take x and I define it to 2, I get back the value. So it kind of does what I want it to do, but yeah, variable assignment's a little bit weird in terms of what it returns. But in this case, I can get away with this. So in this case, if I'm returning this with no other changes to my code, it doesn't change the behavior at all. Where it changes the behavior is if I then do this. Then I'm reassigning what's in my object to be whatever the function returns. Make sense? Yeah. So that by itself, like if I just run this as it is, doesn't change anything. But if I change this over so that this reassigns, then we get the behavior we saw earlier. Make sense? Cool. Okay, any questions so far? How are we doing on time? We got 10 minutes left. Cool. So let's do just a little bit of review here. Somebody give me a noun, preferably a polite one. Frog. Frog works. There's no warts. It's not a toad. Cool. So, if I wanted to find out how many legs the frog had, how would I do it? Nick. His hand beat yours, sorry. Okay. Excellent. We have 4 legs on our frog. Good sign. If I wanted to say my frog is green and have that reflect the color of what's stored in the object, how would I do it? Somebody other than Nick now. Yeah.
Console.log string my frog is, then out the string plus frog dot color.
Bingo. Very good. And last but not least, yeah, I should have done that better. Okay. If I said that he had 27 flies in his belly over 2 days, how would I find out the number of flies per day? Somebody other than the front row. Unless, Kira, you want to jump in. Yes. Front row's winning. Ta-da. 13.5 flies per day. Yummy. Cool. That's working with objects in JavaScript. This is a key skill, but I'm also going to tell you that, like I started off the lecture with, don't assume that you're expected to understand everything about working with objects just by my showing you. You will learn to work with objects by working with objects. You cannot learn to fly a plane by reading a book. So the basic lookup principle, and literally, like I said, going step by step in an object lookup is going to give you the best flexibility and best skill that you have. And I'm going to finish off the lecture with one of my key principles that I give to every cohort, which is the secret to programming. The secret to programming is LSD. Unfortunately, I don't mean acid. That would make this a lot more interesting. It means logic, syntax, and data. And the reason I use this acronym is because every single thing you will ever do in programming, every bug you're going to fix, every feature you're going to have to build, every app you're going to have to scope out, comes down to these three things, without exception. And if you know which one of these three things is causing your problem, it allows you to focus your troubleshooting. So, logic, easy question. Have I given the computer the simple steps to solve the problem as I would solve it as a human? If you can't solve the problem as a human, you can't tell the computer how to do it. So if you needed to loop through a deck of cards and deal it to each player, if you needed to go through all of the accounts at PricewaterhouseCoopers and find out the total amount of money that they manage on a daily basis, if you needed to figure out the temperature from a sensor, you have to figure out the steps that you would do as a human first to solve that problem. Always imagine you are looking at the data as like a stack of index cards in front of you, or it's written on a sheet of paper, and you have to figure out mechanically, analog, what you would do as a human to solve that problem. Only then can you translate that into code. For us, unfortunately, programming is just us telling the computer how to solve the problem in a language it understands. Programming is not math. Programming is us literally speaking the language the computer understands. So the logic part is the hard part. It is us figuring out the problem first and then telling it to the computer. Syntax. Clearly I can't type today. Syntax. We can only answer this question once we figured out what steps we need to tell it to do. So, did I use the correct language? Is the capitalization of these function names correct? Are the commas in the right place? Did I match up my parentheses and my curly braces? You know, in JavaScript, the semicolon is the period at the end of the sentence. That's grammar, that's syntax. And last but not least, sometimes this question might as well come first, because if you don't have access to the data, you're dead in the water. Doesn't matter how good your logic is, doesn't matter how clean your syntax is. If you don't have access to the data, or it's not in the format you expect, you're done. And you have to fix that first. But DSL sounds too much like the line that you buy from TELUS that comes into your house, and LSD is funnier. So, but yeah, these are your three debugging questions. And so now that we're starting to get more complex and we're starting to talk about objects, now is a great time to adopt this as your troubleshooting method. Because if you can ask yourself these three questions about your code at any given point and answer yes, then you're moving forward in a good way. If you're stuck, if you don't know what the next step is supposed to be, now you have three questions that you get to ask that will get you out of every single problem you are in. So that's why I like to give these out at this point. And I encourage you to use this. I'm telling you officially on video, it's recorded, use LSD. Cool. Any questions about this? Yeah.
So
Mm-hmm.
I was wondering if you could explain the difference between for each in loops, for in loops, and for of loops.
Okay. So difference between for each, for in, and for of. Fundamentally, they are all doing the same thing. For each, we're going to get into a lot more tomorrow. For each is a way to loop over an array, and then what you do is you give for each a function, and you're going to run that function on each element in the array. And so JavaScript is automatically going to take that element and pass it into the function for you. So you write for each, you give it a function, and that function gets run on each element of the list. The difference between for in and for of is that for in is going to give you, for example, it changes depending on whether you run it on an array or an object. If you run it on an array, you will get back the element of the array in your variable. So if I say complicated list. Well, actually, let's just do this in the REPL because then we can see it happen. So I'm going to say var x in list. And if I console.log x, for in gives me the index. Yes. So that gives me the index of all of the elements in list. Whereas if I say for of, I get back the values. And that's why when I was answering Nick's question earlier, he was talking about using for in on the object. It gave back the keys of the object. Whereas if I cheat and come back here and copy this one and paste it in, if I do for of object, it complains because it doesn't like to be run on objects. It doesn't like to loop through the values, but on an array, for in gives me the indices and for of gives me the values. On an object, for in gives me the keys and for of gives me errors. Yeah, no problem. But just for demonstration purposes so that you can see it before tomorrow. So my list array, if I do for each, basically what's going to happen is that function is going to get run on every element of that list one at a time. And each time it runs, the element is going to get passed into the function as an argument. And I get that. Cool, no problem. So I will send out all the REPL output that we had and all the code files and the note files that I did. I'll just bundle it all up into a big gist, and I'll send that out to you guys for notes. Cool. Thanks, folks.